May God's peace be on all of you. Our today's lecture deals with carbon sources of fermentation media. Sulfite waste liquor. Sugar-containing wastes derived from the paper pulping industry are primarily used for the cultivation of yeasts. Waste liquors from coniferous trees contain 2 to 3% sugar, which is a mixture of hexoses 80% and pentoses 20%. Hexoses include glucose, mannose, and galactose, whereas the pentose sugars are mostly xylose and arabinose. Those liquors derived from deciduous trees contain mainly pentoses. Usually the liquor requires processing before use as it contains sulfur dioxide. The low pH is adjusted with calcium hydroxide, or calcium carbonate. And these liquors are supplemented with sources of nitrogen and phosphorus. Cellulose. Cellulose is predominantly found as lignocellulose in plant cell walls, which is composed of 3 polymers, cellulose, hemicellulose, and linen. Lignocellulose is available from agricultural, forestry, industrial, and domestic wastes. Relatively few microorganisms can utilize it directly, as it is difficult to hydrolyze. The cellulose component is in part crystalline, encrusted with linen, and provides little surface area for enzyme attack. At present it is mainly used in solid substrate fermentations, to produce various mushrooms. However, it is potentially a very valuable renewable source of fermentable sugars once hydrolyzed, particularly in the bioconversion to ethanol for fuel use. Whey. Whey is an aqueous byproduct of the dairy industry. This material is expensive to store and transport. Therefore, lactose concentrates are often prepared for later fermentation, by evaporation of the whey, following removal of milk proteins for use as food supplements. Lactose is generally less useful as a fermentation feedstock than sucrose, as it is metabolized by fewer organisms. Saccharomyces cerevisiae, for example, does not ferment lactose. This disaccharide was formerly used extensively in penicillin fermentations, and it is still employed for producing ethanol, single-cell protein, lactic acid, xanthan gum, vitamin B12 and gibberellic acid. Alkanes and alcohols. N-alkanes, of chain length C10-C20 are readily metabolized by certain microorganisms. Mixtures, rather than a single compound, are usually most suitable for microbial fermentations. However, their industrial use is dependent upon the prevailing price of petroleum. Methane is utilized as a carbon source by a few microorganisms, but its conversion product methanol is often preferred for industrial fermentations, as it presents fewer technical problems. High-purity methanol is readily obtained, and it is completely miscible with water. Methanol has high % carbon content, and is relatively cheap, although only a limited number of organisms will metabolize it. Also, unlike many other carbon sources, only low concentrations, 0.1 to 1%, are tolerated by microorganisms, higher levels being toxic. During fermentations on methanol, the oxygen demand and heat of fermentation are high, but this is even more problematic when growing on alkanes. Ethanol is less toxic than methanol, and is used as a sole or co-substrate by many microorganisms, but it is too expensive for general use as a carbon source. However, its biotransformation to acetic acid, by acetic acid bacteria, remains a major fermentation process. Fats and oils. Hard animal fats that are mostly composed of glycerides, of palmitic and stearic acids are rarely used in fermentations. However, plant oils primarily from cottonseed, linseed, maize, olive, palm, rapeseed, and soya and occasionally fish oil, may be used as the primary, or supplementary carbon source, especially in antibiotic production. Plant oils are mostly composed of oleic and linoleic acids, But linseed and soy oil also have a substantial amount of linolenic acid. The oils contain more energy per unit weight than carbohydrates. In addition, the carbohydrates occupy a greater volume, because they are usually prepared as aqueous solutions of concentrations no greater than 50%. Consequently, oils can be particularly useful in fed batch operations, as less spare capacity is needed to accommodate further additions of the carbon source. That's it for today's lecture. Don't forget to subscribe. And we will see you guys next time.